Acceleration is a vector quantity. Acceleration, by definition, means the rate of change of velocity. So, if rate of change of velocity, which basically means the change in velocity with respect to time, so mathematically can be written as change in velocity divided by time. It can also be expressed as dv dt, which means difference in velocity divided by difference in time. It can also be written as acceleration equals v minus u upon t, where v represents the final velocity of the body, u represents the initial velocity of the body, and t represents time. This is a formula for calculating acceleration when initial and final velocities are given and the time for the change in velocities is also given. This formula applies when acceleration is constant, when acceleration is uniform. Only then is this formula applicable, and this equation over here is also known is one of the equations of motions that we are going to discuss later. Equations, this is the first equation of motion actually that we have studied right now. Okay, now a property of acceleration. Acceleration by definition is the rate of change of velocity, right? So if I were to draw a velocity time graph of a journey, the gradient of that graph represents the gradient, the slope of that graph represents the acceleration, because acceleration by definition is the rate of change of velocity, and gradient is also the change in y upon change in x, so change in velocity upon change in time. Acceleration can be both positive and negative. Positive acceleration is the acceleration which leads to an increase in the magnitude of velocity, whereas negative acceleration causes a decrease in the magnitude of velocity. Negative acceleration is also known as retardation. Retardation. Okay, so negative acceleration causes a decrease in the magnitude of velocity. So this is all about acceleration. Now let's move forward towards a more important topic. Okay, now a lot of questions from this topic have been asked in the previous exams. So listen carefully now. Motion in one dimension, meaning motion in a straight line. There are three types of motions in one dimension. The first type is the uniform motion. Second type is the uniformly accelerated motion, and the third type is the variable motion. Okay, uniform motion is a motion in which acceleration is zero and velocity or the speed is constant. The speed does not change. So if I have a body that keeps, if I have this, let's say I have a small car and it keeps moving with a velocity of 10 meters per second, and this 10 meters per second speed or the velocity does not change, we say, and this body keeps moving in a straight line, we say that this body is undergoing a uniform motion. The velocity and the speed remain constant. So when the speed or when the velocity stays constant, so acceleration obviously will become zero, because acceleration is the change in velocity upon time. When the velocity is not changing, acceleration becomes zero. The second type, and the most important type, is the uniformly accelerated motion. This is the motion in which the velocity changes. The velocity is not constant, but rather the acceleration is constant. And in such a motion, the equations of motion are applicable. There are five different equations of motions. The first equation of motion is directly from the definition of acceleration, which we just did. Acceleration is a change in velocity upon time. So change in velocity is basically the final velocity v minus the initial velocity u divided by time. This is the first formula or the first equation of motion that we've studied. The second equation of motion, which is also a very important one. This is a very important one and has been frequently tested in the past year papers. S is equal to ut plus half at squared. S is basically the displacement. S is the displacement, or in some cases it is also referred to as the distance, but mostly it's the displacement. U is again the initial velocity, T is the time, and A represents the acceleration. So when displacement is given, acceleration and time are given, and initial velocity is asked, this equation can be used. This equation cannot be used to calculate the final velocity because the final velocity v is missing from this equation. Similarly, in the first equation, the distance, the s was missing. So the distance cannot be calculated from the first equation. Now let's look at the third equation. In the third equation, v squared equals u squared plus 2as. This is also a very important formula and has been frequently tested in the past year papers. V squared, again V is the final velocity, U is the initial velocity, A, S are acceleration and displacement. This formula cannot be used to calculate the time because time t is missing. Okay, let me write it down. Time cannot be calculated from this formula. The final velocity cannot be calculated from this formula, and the displacement cannot be calculated from the first equation. The fourth equation is basically used when the acceleration is not given. When the acceleration is not given, this equation can be used and everything else is given. And then the last equation, s is equal to vt minus half at squared, when the initial velocity is not given, u. But this is the least tested formula. The first four are the more important ones, so better learn them for your exams. So that's it for the uniformly accelerated motion. The third motion is variable motion. In this motion, neither the acceleration is constant nor the velocity is constant. Both of them are variable, and this motion is not in our syllabus. So the only two motions in our syllabus are the uniform motion and uniformly accelerated motion. The equation of motion that is applicable in the uniform motion is the basic speed formula, which came directly from the definition of speed. Speed is the rate of change of distance. So speed is equal to distance upon time, and distance upon time, distance can be represented as s, time can be represented as t, v can be represent speed. So s is equal to vt is the only formula. This formula came from the rearrangement of the upper form. This is the only formula that is applied on the uniform motion. Thank you.